Okay, so weathering. This is about weathering and climate. It's the term that describes all the processes that break down rocks in the environment near Earth's surface. There are two main kinds of weathering. There's mechanical weathering, which tears apart rocks by breaking them or physically destroying them. Mechanical processes physically fracture or pull rocks apart at a large scale or a small scale. Chemical weathering is the breaking down of rocks atom by atom through chemical reactions. Important in this is water, which helps dissolve things and carry chemicals from site to site. I'm just going to show you a couple of different examples. So mechanical weathering is like if you take a hammer and smash. And there are some of the mechanical weathering processes. We have frost wedging, exfoliation, thermal expansion and contraction, crystal growth, tree root growth, and abrasion. If you look at your worksheet, you just have two questions to answer. We have what is weathering? Weathering is the breaking down of rocks by chemical or physical means. So it's when you break rocks into smaller pieces. Watch the different simulations. So we haven't started that yet, but here, what are some ways that mechanical weathering can occur? So we have root or ice wedging. We have abrasion, exfoliation. We have thermal expansion. And crystal formation. Okay, so get those down, and then we're going to go back and look at a couple of the animations. Okay, so just playing with these, we have frost wedging, which is mechanical. As the water freezes, it expands and breaks apart the rock and actually pushes the rock off. Okay, we have exfoliation, which is when layers of the rock peel off of the rock face. Thermal expansion, which is when crystals of the rock expand as they heat and cool. They expand when they heat up, and they contract and get tighter when they cool down. And as they do that, it causes the pieces of the rock to eventually break off. Repeated heating and cooling cycles slowly break mineral grains apart. Okay, next we have crystal growth. So if salt forms crystals in between mineral grains or in between any parts of the rock, they will actually expand and push the pieces of rock apart. Tree roots, mechanical weathering. Root wedging is when we have the roots growing into rock and pushing it apart and breaking it into smaller pieces. Abrasion is when rock pieces or even like sand and sediment crash into each other and break it down. So like water, wind, glaciers, they all carry rock to break it down through abrasion. Then we have chemical weathering, which is breaking down rocks one atom at a time using chemical means. So this is from water dissolving a rock. This is rusting, or when a rock that contains iron comes in contact with oxygen, it oxidizes. This is hydrolysis. Hydrolysis is when chemical reactions take place. In this, the feldspar is converted to clay by hydrolysis. Clays absorb water and expand, breaking apart mineral grains. So it actually chemically changes the rock so that it behaves differently. Okay, and that is all. We're going to go on to the next site. Okay, so this site gives us some information. So we want labels on so that we can see that we have sandstone, limestone, and a small cave. All right, so it's scene number 1. If we add water, okay, this is what happens in the future. you want to turn the labels on so you can see what happens. And this one is already filled in, but it's so you can see an example of what happens. We have sandstone, we have stalactites and stalagmites forming, and those are these formations that happen in caves. And we have a large cave, whereas before we had a small cave. So water helps form caves, dissolve the limestone, and create stalactites and stalagmites. So if you look at your paper, it's already filled in. So scene number 1, the weathering effect was water. Before the weathering, we had limestone and sandstone. After the weathering, we had stalactites and stalagmites, and you can also put a large cave. Okay. Now down here, scene number 1, we're going to do again, but this time we're going to use O2, which is oxygen, as our weathering effect. So now these things don't happen alone. Sometimes we have both water and oxygen affecting a cave. But this is so you can see how they affect them differently. So if I click on O2, I go from having sandstone to having red sandstone because oxygen causes oxidation. Oxidation makes the iron in that sandstone rust. And I still have everything else the same. So if I go back to my paper, before weathering I had sandstone. After weathering, I had red sandstone. Okay, so after weathering, I ended up with red sandstone because of oxidation. Okay, so if you didn't quite understand that, make sure you know it's because of oxidation, which is when something rusts, just like your bicycle will rust if it's left out and exposed to the weather. All right, so the next one is scene 2. So here's scene 2. We have a face on the mountain. We have snow. We have a mountain, and we have a river. So I'm going to go over to my worksheet and fill in what I have before weathering. So I have a mountain, a face carving, snow, and a river. All right. So I will make this a little smaller. I'm trying to use a different program this time so that we can see the words hopefully. Okay, so mountain, face carving, snow, and river. And if we look at our situation here, our first one's going to be freeze and thaw. So in the future, labels on, we have a talus slope. So that is from a piece of this breaking and sliding down the mountain. We have cracks and a talus. So I'm going to go back to my handy dandy paper and write cracks and a talus forms. Alright, so now we're going to look at scene 2 again, and you can just copy the same thing into the other box, and that is not what I wanted to copy. That is the website. Okay, so we have mountain, face carving, snow, and river, and I'm just going to fit that in that box. Alright, so this was freeze, thaw. Let's see what the other weathering effect is going to be. Alright, so we have water. So water, see how the face is starting to disappear? That's because the water is dissolving the minerals. Okay, so we have a dissolved carving. So the carving is dissolving. Okay, so the water is like washing it away by dissolving the salts and minerals that make up that rock. All right, let's go to scene 3 now. Scene 3, we have a beautiful pine trees and snow. So we're going to see what happens when vegetation grows. Okay, so underneath this snow, is rock, and soil. And as this tree grows, the roots are breaking apart the rock that is below the soil line. Okay, so on our paper we can put vegetation. We have pine trees and snow. And then after the weathering, the pine tree, we have root wedging. We'll put root wedging. Okay, because it has broken apart the rock using the roots of the tree. Okay, scene 3 again. We have freeze and thaw. So here we have a very similar situation happening. We have the rocks being broken apart, but this time they're being broken apart by ice wedging. Okay, so with freezing and thawing, we have ice wedging. Helps if my hand is on the right key. Okay, freeze, thaw. We have pine trees again. And we have ice wedging. Okay, last scene. Scene 4, we have a house. Now keep in mind we have a house, a bike, a sidewalk, and a tree. So we're going to see what vegetation does to this. So we have the tree has grown and root wedging has cracked the house and the sidewalk. Okay, nothing really else is going on from the vegetation. So we have vegetation. We have a tree, a house, a sidewalk. The bike was not really affected, so we're not going to include that. So tree, house, and sidewalk. Now, the root wedging cracked the house and the sidewalk. Okay, and I'm going to just shrink the font down to 24. Okay, and fit that up there. All right, and then the last one, we're looking at oxidation. So we have a rusted bike in this situation. So if you look at this one, we have oxidation. So O2, we have a bicycle, and we have rust forms on bike. Okay? And that is it